Hey, welcome back, Algebra 2 students. Today we're looking at 4-13 Exponentials and Logs Part 2. So we're continuing this idea of interest because it's one of the things that you guys will probably deal with in your adult lives. So simple interest is rarely used. I don't even know why I really talk about it anymore, but what it is that we don't get more interest for the more money we earn, because as we're earning money, our investment is growing, right? But in simple interest, we just get the same amount each time. So if the simple interest is 3%, right? Oh, I forgot to put how much money we put in here. Okay, so let's see. Let's make it up. Let's say we invested $1,000. Okay, for a simple interest of 3%, 3% of $1,000 is going to be $30. So person A is going to make $30 every time. Or maybe if we're adding this up. So after the first year, they're going to get $30. The next year, they're getting $30 more, so they have $60. And then in year 3, we're going to get $30 again, which is $90 total. Okay, which is nice because we're gaining money. But if we compound our interest annually, what that means is we're going to get $30 the first year for person B, right? And then what we have there is going to be 1,030, right? So 1,030 times 0.03 is going to give us 30.9. So this is going to be $60.90, which is not a lot more, but it is more, right? And then we're going to take that and we're going to do our compound interest on the new value, 1060.9 times 0.03, and we're going to get 3182. So that's going to be $92.73, right? So you can clearly see that, well, the first year it's going to be the same, right? But after year 2 already, person B is greater, and it's going to continue to be greater as many years as it goes on after the first year. So compound interest is going to get you way more money than simple interest, and I'm not really sure any times that we do simple interest to begin with. Okay, so for part 2, we're interpreting our exponential function. It's asking us for initial. Remember, initial is always the number in front of the parentheses, so we start off with 400, whatever our unit is. Let's assume it's dollars. The second part is asking growth or decay. So inside of our parentheses, a growth is greater than 1. Decay is less than 1. So we notice that 0.93 is less than 1. So this is going to be a decay. And then it's asking what percent change each year. So the percent change from the inside is going to be the difference from 1. So notice this is going to be 0.93, which is 0.07 negative change, right? Because it's negative 0.07 away from 1. Now, if it were something bigger, like 1.013, then this would be a growth in here, right? Because it's greater than 1. And the percent change each year, oh, I guess it's asking what percent, so we should say this as a percent. So, oops, let's not cancel that out. Remember to change from decimals back to percents, we just got to move our decimal place 2 to the right. So this is actually negative 7%. Okay, likewise here, if we're looking at the percent change, it's 0.13, which is 1.3%. And then this is a positive, right, because it's growing. If it were 1.013 inside. Okay. Now on to the next one. Let's change colors here. We have a table and it's asking us to write an equation. So the important parts, when we know that we have an exponential function, first of all, we know we have an exponential function if it's changing by multiplying or dividing each time. So notice here we're multiplying by 3 each time. And then in order for us to write our equation, it's pretty easy. The initial value is the f of 0, right? So the initial value is 9. I'm going to say y equals 9. And then the change is going to be the base to the x. And then we're done. So pretty simple once you understand what we're looking for. We're looking for initial value and the change. Now keep in mind, if this were decreasing, I'm just going to draw it out here. Let's say we're going to do 8, 4, 2, 1. So each time we're dividing by 2. And let's, I don't know, 1, 0, 1, 2. Okay, if we're doing it this side, this would be our initial value, right? F of 0 is 4. And because we're dividing, we're going to say 1/2, right? Because we're halving each time. So just be careful. If you have a division, it should come out as some kind of fraction. Okay, on to the next one. So we're going to practice rewriting logs as exponents and exponents as logs. So remember, this is our base. This is our exponent. And then this is our value. And then same idea when we're doing this. 8 is our base, 2 is our exponent, 64 is our value. So we're log base 8. The value is 64 and our exponent is 2. Okay, number 6, same idea. We're rewriting this as log. So remember when we do log based e, that's ln. So ln, our value is 8 and our exponent is y. And then for 7, ln means base e, right? So e to the exponent equals the value. Okay, so this one, next one says log base 6 of 36 equals. So what it's saying is 6 to the what power is 36. Well, I know 6 squared is 36, right? So this is going to be 2. Now for 9, the base is 4. To the what power is 1/64. This one's a little bit tricky, but we know that it's going to end up being reciprocal, right? So I know 4 times 4 is 16 times 4 again is 64, right? So that's 3. But because this is the reciprocal of 64, then we say negative. So x has got to be -3. Okay, and then the last one, it's asking us solve log base 81 of x equals 1/2. So we're going to rewrite this as an exponential. 81 to the 1/2 equals x. Remember that when we have our rational exponent, the top is the power, and then the bottom is the root, right? So we're taking the square root of 81 to the first power. We really don't have to use the first power because it's implied. So the square root of 81 is going to be 9. Okay, that's it for today. Just another quick review on logs and exponentials because we have our end of course coming up and we have ESPA coming up for the 11th graders. So yeah, it's good practice. Good job.